Hi guys and welcome to another video of IGCSE on fingertips. Today we are going to solve chemistry paper 4-1 of May-June 2021. The paper is of 80 marks. It's a subjective structured paper. Let's get started. Let's start with the question number 1. Give the name of process that is used A to produce ammonia from nitrogen. That process is known as Haber's process. Right? That process is known as Haber's process. Okay. To separate nitrogen from liquid air. Now we are going to liquefy the whole air and then separate nitrogen from it. So that will be fractional distillation. We are taking nitrogen and air towards their boiling point and we are separating them according to their boiling point, right? Nitrogen will be the first one to become gas. So fractional distillation. To produce bromine from molten lead bromide, electrolysis, right? On the positive electrode, bromine will be formed. To separate undissolved solid from an aqueous solution, if it's an aqueous solution, you can filter. So I'll write filtration. Okay, next question. To produce amino acids from proteins. Now proteins are polymers, amino acids are monomers. So you can use hydrolysis to break the amide linkage. And to separate a mixture of amino acids, obviously chromatography, right? It will separate the solutes mixed in a common solvent. That's your first question. Question number 2. Complete the table to deduce the number of protons, electrons and neutrons in the magnesium atom and copper ion shown. Identify the atom or ion represented by the final row. Okay, let's see. So Mg 25 and 12. If it has 12 protons and 25 nucleons, right? This top part is the number of nucleons. If 25 is the number of nucleons, then 25 minus 12 will be the number of neutrons, which is equal to 13. Okay. Now if copper is 2 plus, right, and it contains 29 protons, the number below is protons. So let's just simply write 29 here. Okay. And let us first identify what is this element. Number of protons 17, it is chlorine. Okay. Then what is the number of protons? 17. So I'll write 17 here. Right? We have 18 electrons and 20 neutrons. Right? So we have one more electron compared to proton. So the charge on chlorine is negative. Right? And we have 20 neutrons. So 20 plus 17 is equal to 37. So 37 nucleons. Okay, let's get back to this. Magnesium has no charge. So the number of protons and electrons are equal. Copper has 2 plus charge, which means it will have 2 less electrons compared to protons. 27. Okay. Electrons can be more or less. The proton number stays same. It is a constant, right? Neutron number can change depending on if it's an isotope or not. So that's your second question. Let's get to our third question. Right? Question number 3. Potassium reacts with chlorine to form potassium chloride, KCl. Write a chemical equation for this reaction. Okay, it's simple. Potassium is a metal, so it's just K. Chlorine is a diatomic gas, so I'll write Cl2. This will form KCl, right? Each of them will lose one electron. But there are 2 chlorine. So to balance that, I need to write 2 KCl here. And to balance 2 potassium here, I'll write 2 here, right? This goes, the 2 marks is 1 mark for writing the equation and the second mark is for balancing the equation. Okay? Right. Next question. Potassium chloride is an ionic compound. Complete the diagram to show the electronic arrangement in the outer shells of ions present in potassium chloride. Give charges on both ions. Now I know that on potassium the charge is +1 and on chlorine the charge is -1. Right? They lose and gain 1 electron respectively. Potassium loses electron, that is gained by chlorine. Now you can look at your periodic table while doing this sum and find out that the atomic number of potassium is 19 and atomic number of chlorine is 17. Now if potassium loses 1 electron, it will have 18 electrons present in its electronic shell, and if this gains 1 electron, this will also have 18 electrons in its shell, but 1 electron has gone from potassium to chlorine. Right? Let's get started. So there are 1, 2 and 3, 4, 5, 6, 7, 8, 9, 10 electrons, but we need 18. Right? So we'll draw 8 in the outermost shell. 1, 2, 3, 4, 5, 6, 7 and 8. Right? Then let's go to chlorine. Chlorine also must have 8 electrons in its outermost shell. It has same configuration. Right? So let's make dots here. 1, 2, 3, 4, 5, 6, 7. But the 8th electron is from potassium. We must signify that by drawing a cross. This means that this electron came from potassium. Right? This is your answer. Let's get to the next question. Question C. Molten potassium chloride undergoes electrolysis. What is meant by the term electrolysis? In electrolysis, we are passing electricity through a liquid, right, to break its ions. So I'll write breaking of ionic bonds by passing electricity in molten or aqueous form. Right? They must be in molten or aqueous form, otherwise electricity will not pass through them and they will not break the bonds. Okay. Number 2, name the products formed at positive electrode anode and negative electrode cathode when molten potassium chloride undergoes electrolysis. Now let's just find out that they are talking about molten potassium chloride. Okay, it's not aqueous, it's not concentrated, it is molten. So the only ions present are potassium and chlorine. Right? Potassium being the positive ion, it will go to the negative electrode. Right? It will be attracted toward the negative electrode, so it gets attracted towards cathode. Chlorine being the positive ion gets attracted towards anode. So when electricity will pass, chlorine gas forms at anode and potassium solid, potassium solid forms at cathode. Right? It forms at cathode. Question D. Concentrated aqueous potassium chloride undergoes electrolysis. Now see, they have changed the term. They have written it's not molten anymore, it is aqueous. So there are H plus ions present. Potassium is more reactive than H plus ions. So what will happen at the negative electrode? At the negative electrode, H plus ions are attracted. They gain 1 electron, they get reduced and form H. But H cannot form. Hydrogen is a diatomic gas. So I'll write 2 here. Right? We'll change this to 2 and I'll write 2 here. This is the ionic half equation for reaction at the negative electrode. Name the product formed at the positive electrode. At the positive electrode, there is a competition between chlorine and OH. Right? OH is also there now because it is aqueous, but chlorine forms first because this is concentrated solution. Right? This is concentrated solution. So name the product at anode. It's still chlorine. Okay. let's go to the next question. Name the potassium compound that remains in the solution after electrolysis. Electrolysis of concentrated aqueous potassium chloride. So what are the ions? You have potassium, you have hydrogen, you have chlorine, and you have OH, right? So these are the positive ions and these are the negative ions, out of which hydrogen and chlorine gets formed at cathode and anode respectively. So what forms at the solution? What is remaining in the solution? Potassium hydroxide. They have written name the potassium compound, right? Try to write the name, not the formula. So I'll write potassium hydroxide. That is the compound forming, potassium hydroxide. Okay, let's see next question. Complete the dot and cross diagram to show electron arrangement in a molecule of chlorine. Show the outer electrons only. You don't need to draw the three shells that we have drawn in the previous question, right? Just draw the dot and cross. So for left hand side chlorine, I am going to choose crosses 1, 2, 3, 4, 5, 6 and 7th is shared with this chlorine. For right hand side chlorine, let's take dots. So 1 is shared with this chlorine. 1, 2, 3, 4, 5, 6 and 7. Both the chlorines have 7 electrons in their outermost shell. They are sharing one. They are forming a single bond and forming a diatomic gas. Okay. Question F. The melting points and boiling points of chlorine and potassium chloride are shown. Right. Okay. What's happening here? Let's see. Right. Deduce the physical state of chlorine at 75 degrees Celsius. Use the data in the table to explain your answer. Okay. Let's see what the data tells us. The data shows, okay, the data shows that chlorine is melting at minus 101 degrees Celsius and boiling at minus 35 degrees Celsius, right? We have to deduce the physical state. Now, if I draw a number line, minus 101 is here, minus 35 is here, right? Minus 35 is greater than minus 101 and minus 75 is going to fall between them, right? So what will be the physical state? Melting. So it's solid here, liquid here and gas here, correct? Minus 35 is boiling point, so it will be gas here. So what is the physical state? The physical state of chlorine is liquid. What is the explanation? The explanation is that the temperature is greater than minus 101 but less than minus 35. It's between the melting point and boiling point. That is why it is liquid. Okay. Question number 2, part 2. Explain in terms of structure and bonding why potassium chloride has a much higher melting point than chlorine. Your answer should refer to type of particles held together by forces of attraction. So type of particles, KCl is ions and Cl2 are molecules. Okay, type of forces of attraction between particles. In KCl it's ionic attraction and in Cl2 it is molecular attraction. Relative strength, the molecular attraction between Cl2 molecules is weaker compared to the ionic attraction. Okay, so let's just quickly write that down. Type of particles: in KCl, ions are held together, right, by ionic forces, and in Cl2 molecules are held together by intermolecular forces, right? Two Cl2 molecules are attracting each other And what is the strength of the force of attraction? Chlorine has lower boiling and melting point. So the force of attraction in chlorine is weaker than KCl. This will be your answer. Okay, let's go to question number 4. Dinitrogen tetraoxide decomposes into nitrogen dioxide. The reaction is reversible. Okay, a colorless gas becomes a brown gas. A gas syringe containing a mixture of dinitrogen tetraoxide, right? Okay, dinitrogen tetraoxide and nitrogen dioxide gas was sealed and heated. After reaching equilibrium, the mixture was pale brown color. Why? Because it did contain some brown gas. What is meant by the term equilibrium? Equilibrium is when the rate of forward reaction is equal to the rate of reverse reaction and the concentration remains constant, right? The term equilibrium means rate of forward reaction is equal to rate of reverse reaction and concentration of reactants and products, right? Both doesn't change, right? The reaction is taking place, but the rates are balanced off in such a way that the concentration does not change. Okay. The plunger of the syringe is pushed in. So the syringe we saw, okay, it's pushed in like this. The plunger is pushed in, right? What will happen? Inside the syringe, the pressure is going to increase. The temperature does not change. The mixture initially turns darker brown. After a few seconds, the mixture turns lighter brown because the equilibrium shifts to the left. Explain why mixture initially turns darker brown. What will happen? First, the concentration of brown gas is going to increase because it is enclosed inside a smaller space. So we will write concentration of, or we can just simply write the pressure increases, right? We can simply write the pressure increases, which brings the NO2 gas together. So I will write pressure increases, hence concentration, or the gas is compressed. I'll write concentration increased, right? It means the gas will get dark brown. Explain why position of equilibrium shifts towards the left. It shifts towards the left because the number of moles of gas are less on the left hand side. The number of moles of gas lesser on left, right? That will be your answer. Okay, next part, question E. The forward reaction is endothermic. So dinitrogen tetraoxide becoming nitrogen dioxide is endothermic. It takes in energy. State what happens to the position of equilibrium when the temperature of the mixture is increased. Now guys, what happens is, if the forward reaction is endothermic, the reverse reaction will be exothermic because this is a reversible reaction. So what will happen to the position of equilibrium? The endothermic reaction will be enhanced, right? But the exothermic reaction will not be enhanced as much as the endothermic reaction, right? So it shifts, it shifts to the right, correct? Now State what happens to the rate of forward reaction and the rate of backward reaction when the temperature of mixture is increased. As the equilibrium is shifting towards the right, the rate of forward reaction increases, right? But what happens to the rate of backward reaction? Now see, what is happening is, when you increase the temperature, the successful collisions increase. So the rate of forward reaction and rate of backward reaction both must increase. This may create a confusion that if both the rates are increasing, then why does equilibrium shift towards the right? Then a simple understanding is that the change in rate of forward reaction is greater than the change in rate of backward reaction. That is why forward reaction happens more than backward reaction, right? That is why the equilibrium shifts towards the right. Okay, the rate of reaction increases in both the cases. Okay, question number 5. This question is about salts. A. Salts that are insoluble in water are made by precipitation. Lead iodide is insoluble in water. All nitrates are soluble in water, or sodium salts are soluble in water. You are provided with solid lead nitrate PbNO3 twice and solid sodium iodide NaI. Describe how would you make a pure sample of lead iodide by precipitation. Your answer should include practical details, a chemical equation of precipitation, reaction. So what are we going to do? We are going to make solutions of the soluble salts, mix them, obtain precipitate, remove this precipitate by filtration, and we'll have our required salts, right? So let us just start with an equation. What we are going to do? We are going to take PbNO3 twice. We are going to add sodium iodide to it, which will form sodium nitrate. Sodium nitrate is soluble, and PbI2, right? To balance this, NaNO3 is 2 times, so sodium 2 times here, sodium 2 times, iodine 2 times, so NaI will add 2 here. Now just to understand this equation better, I will add state symbols, right? This is soluble, this is soluble as well, this is also soluble, but this is solid, which means lead iodide comes out as a precipitate. It is the precipitate of our reaction. So we are done with the precipitation reaction equation. Let us now write down what happens. Take both salts in separate test tubes, add water, right? Both are soluble. Add water and make their solutions. Add both solutions in a beaker and let precipitate form, right? This precipitate is PbI2, right? Filter this precipitate, filter and wash with water, right, to remove any impurity. Wash with water to remove any dissolved impurities in water. So wash with water and dry the crystals to obtain solid PbI2. That's your answer. Now let's go to next question. Nitrates decompose when heated. When hydrated zinc nitrate is heated, oxygen gas is given off. Describe a test for oxygen. Oxygen is the supporter of combustion. So test is Test is of glowing splinter. Glowing splinter, right? We'll take glowing splinter near the oxygen, right? What will happen? It relights, right? Glowing splinter relights. Complete the equation for decomposition of hydrated zinc nitrate. Okay, so let's start with zinc. Zinc is twice here, so simply add 2. NO2, now nitrogen is twice, so 2 into 2, 4, right? Nitrogen is 4 times, it's nowhere else. You have to keep 4 here, right? Now let's count the number of oxygen, or even hydrogen will do, right? So 6 twos are 12, 12 twos are 24 hydrogen are present. H2 is already there. So if you multiply 12 here, you will get 24 hydrogen. Now just for our satisfaction, let's also total the oxygen, right? Let's also total the oxygen. 3 twos are 6, 6 twos are 12, 6 ones are 6 and 6 twos are 12. So 12 twos are 24. Here 2 plus 8, 10, 10 plus 2, 12, 12 plus 12, 24. So this is a balanced reaction, 2, 4 and 12. Okay. Part C. Some sulfates are hydrated. When hydrated sodium sulfate crystals Na2SO4XH2O are heated, they give off water. Okay, this is the equation. A student carries out an experiment to determine the value of X in Na2SO4XH2O. Step 1. Hydrated sodium sulfate crystals are weighed. Step 2. Hydrated sodium sulfate crystals are then heated. Step 3. The remaining solid is weighed. Okay, let's see what happens. Number 1. Describe how the student can check that all the water has been given off. What is the answer to this? When we want to obtain pure dry crystals, we heat them to constant mass, right? We heat them to constant mass. So what he should do? He should take the hydrated sodium sulfate crystals, heat them, again weigh them, again heat them, again weigh them, until unless he obtains a constant mass. So what will your answer be? Your answer will be, he must repeat step 2 and step 3 until he obtains a fixed mass of the salt, right? When will he obtain fixed mass? When all of the water is evaporated out of this, right? Okay, next question do we have? Yes, question number 2. In an experiment, 1.61 gram of sodium sulfate .xH2O is heated until all the water is given off. The mass of sodium sulfate remaining is 0.71 gram. The relative molecular mass of sodium sulfate is 142, water is 80. Determine the value of X using the following steps. Number 1. Calculate the number of moles of sodium sulfate remaining. Now, what is the number of moles? Number of moles is measured mass upon relative molecular mass. So, measured mass is 0.71 gram and the relative molecular mass is 142. So, 0.71 divided by 142, you will get 5 into 10 to the power minus 3 moles. This is the number of moles of sodium sulfate. Second, calculate the mass of H2O given off. For that, we will need to subtract, right? Let's just note this down, that there was 1.61 gram of the hydrated salt, but the constant mass was obtained at 0.71. This means how much oxygen is there? 1.61 minus 0.71. So you have 0.90 grams, right? So that is your answer. They are asking mass. So your answer is 0.90 gram. Okay, we have that accuracy. That last zero is our accurate answer due to presence of these 1. Calculate the number of moles of H2O given off. So again, number of moles is measured mass upon relative molecular mass. We have been given that the relative molecular mass of water is 18 and the measured mass is 0.90. So dividing that, right, our answer is 0.05. Okay, 0.05. Okay, for comparison, what we are going to do, we are going to finally compare it, right? So let me change this also to decimals. 0.005 is equal to 5 into 10 to the power minus 3. Now determine the value of x. How are we going to determine the value? By comparing. Okay, what do we have? We have Na2SO4 dot XH2O. Okay, for every 1 mole there are x moles of water, correct? We just found out that for 0.005 moles of sodium sulfate there are 0.05 moles of water. So on cross multiplying, you have 0.05 upon 0.005 will be equal to x, correct? Let's divide this quickly. You have 0.05 divided by 0.005. This is 10. The value of x is 10 for us. Okay, let's go to the next question. Question 6. This question is about iron. Iron is extracted from its main ore in a blast furnace. Okay, this is the diagram of blast furnace. Name the main ore of iron used in blast furnace. The main ore is hematite, right? Okay. Name the substance that enters the blast furnace at A. Okay, let's have a look at the blast furnace. Air is going to enter from A, right? So that combustion can take place. So let us just quickly write air. Name the substance that leaves the blast furnace at B. Slag, because molten iron is extracted from the bottommost outlet. Above it, slag is going to float because it is less dense than iron. Give 2 reasons for using coke in the blast furnace. First of all, it is a fuel, right? It is the one that is giving out the exothermic reaction. It is fuel for reaction, right? It is used as a fuel. Second one, coke becomes carbon dioxide, reacts with more coke, becomes carbon monoxide. So it is just going to act as a reducing agent. Okay, so I'll write acts as a reducing agent. Okay, next question. Another ore of iron is iron pyrites. Iron pyrites contain positive ion Fe2+. Deduce the formula of negative ion in FeS2. Okay, so FeS2 is present, right? This has a positive 2 oxidation state. This will naturally have a -2 oxidation state because they are neutral. So if 2 sulfur have a -2 oxidation state, then 1 sulfur is going to have oxidation state S-, right? Okay, next question C. Iron is a transition element. A list of properties of iron is shown. Iron is a good conductor of electricity. Iron forms soluble salt. Iron forms colored compounds. Iron has variable oxidation states. Iron acts as a catalyst. Iron forms a basic oxide. Give 2 properties from the list in which iron differs from group 1 elements. Group 1 elements, they cannot act as catalyst, they do not have variable oxidation state, they cannot form colored compounds, right? So we can write any of these three. We have to write just two. So I'll write iron forms colored compounds and iron has variable oxidation state. Variable oxidation state. Okay, next question. Give two properties from the list in which iron is similar to group 1 elements. Okay, iron is a good conductor of electricity. Group 1 elements are good conductor of electricity. Iron forms a basic oxide. Group 1 also forms a basic oxide. Just let's copy it down. Iron is a good conductor of electricity and iron forms basic oxide. These are the two properties agreeing with the first group elements. Steel consists mainly of iron. Iron forms rust when it reacts with water and oxygen. Magnesium blocks can be attached to the bottom of steel boats. The magnesium does not completely cover the steel. Explain how magnesium blocks prevent iron from rusting. Simply, magnesium is more reactive than iron, so it will oxidize itself before iron. Okay, so we'll write magnesium being more reactive than iron forms oxide before iron, preventing iron from rusting. Right? This is how it will prevent iron from rusting. Okay. Question part 2. Explain why replacing magnesium blocks with copper blocks will not prevent the bottom of the boat from rusting. Simply because copper is less reactive than iron. Because copper is less reactive than iron. Right? It will not react before iron, rather it will react after iron. Okay, let's go to the next question. Question number 7. Many organic compounds contain carbon, hydrogen and oxygen only. An organic compound V has following composition by mass. Carbon is 48.65%, hydrogen 8.11% and oxygen 43.24%. Calculate the empirical formula of compound V. Now we are going to assume here, because we want to find out empirical formula, we'll need to find the number of moles. So we'll assume that the compound is 100 grams, right? In that case, your carbon is going to be 48.65 grams. Hydrogen is going to be 8.11 grams and oxygen is going to be 43.24 grams, right? Now we need to find out the moles in which they are combining. So divide each of them by their relative atomic mass, right? Relative atomic mass. So 48.65 divided by 12, you get 4.05. 8.11 divided by 1 is going to be 8.11 and 43.24 divided by 16 is going to give you 2.70, right? 43.24 divided by 16 is going to be 2.70. Now we must find their smallest ratios in which they divide. So what we can simply do, we can take this smallest number, divide everything by the smallest number to make a easy ratio. So this will be 1, 2.70 divided by 2.70 is 1, 4.05 divided by 2.70 is equal to 1.5, right? And 8.11 divided by 2.70 is equal to 3.00. I'll take this as a 3. Now, this is still not a whole number ratio. So, let us multiply all of them by 2. This will give you the smallest ratio. So, I can therefore write that carbon's smallest ratio is 3, hydrogen's smallest ratio is going to be 6, and oxygen's smallest ratio is 2, which is our empirical formula C3H6O2, right? Okay. Next question. Compound W has empirical formula CH4O and a relative molecular mass of 32. Calculate the molecular formula. Now, we know that molecular formula, let's write molecular formula will be equal to, okay, before we find out molecular formula, that N is equal to empirical mass upon relative molecular mass, or measured mass. Let's say it is measured mass, that will give you the N. Okay, let's first find that empirical mass of CH4O. So it's 12 plus 4 plus 16, 20 plus 12, 32, and you have measured relative molecular mass is also 32. So the ratio is 1, right? So the number of molecules need to multiply it with 1 to obtain molecular formula. Multiplying the formula with 1, you get CH4O, right? This is the formula. Okay. Part C. Compounds X and Y have same general formula. X and Y are both carboxylic acid. Compound X has a molecular formula C2H4O2. Compound Y has molecular formula C4H8O2. Deduce the general formula of compounds X and Y. Now, see, the thing about carboxylic acid is they will always contain this much, right? They will always contain this much. This will be obviously attached to an H, but they will contain this much. So, in my formula, if I ignore carbon and hydrogen, right, they are written separately. So, oxygen, I can always say there are two oxygen in an acid, right? So, I'll start with that. I'll write O2. Okay. Now, if you observe, the number of hydrogen are double the number of carbon. C2H4, C4H8, right? To just make sure, let's just write down the formula of C3, right? What happens when there are 3 carbon? Okay, this carbon will have oxygen, and this is the carbon containing acid group. So 1, 2, 3 and 4. So this carbon will have 2 hydrogen. This will have 3 hydrogen. Okay, for 3 carbon you have 1, 2, 3, 4, 5 and 6 hydrogen. Yes, the formula works, right? We were just cross checking, does our formula work or not. So I'll write CnH2nO2. This is your general formula. Okay. Draw the structure of compound Y. Show all of the atoms and all of the bonds. Okay. First, let us see. Compound Y is C4H8O2. So we are going to draw C4H8O2. So 4 carbons, right? Let's say this carbon contains the acid group. Then hydrogen, 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 hydrogen. Now, if you count the number of hydrogen, they are 8. We have 2 oxygen and 4 carbon. What is the name of this compound? Meth, eth, prop, bute. So the name of compound is butanoic acid, right? This is the name of this compound. Give the name used to describe a family of similar compounds with same general formula, similar chemical properties and same functional group. It's simple, it is homologous series, right? Homologous meaning same general formula, similar chemical properties and same functional group. Okay. Part D, propene is an unsaturated hydrocarbon. Unsaturated meaning there are at least one double or triple bond. The formula of propene is shown. CH3, CH double bond CH2. State the color change observed when propene is added to aqueous bromine. What will happen? Addition reaction will happen. Bromine will get attached to this and this. Bromine will get attached to the two carbons that have the double bond, right, making them saturated. So what will happen? The color of bromine goes from brown, right, it goes from brown to colorless. Why? Because the element bromine is forming a compound, right, it is getting added to propene. Propene can be produced by cracking long chain alkanes. Pentadecane C15H32 is cracked to produce an alkane and propene in 1:2 molar ratio. So the number of moles of other compound produced is half of the number of moles of propene produced. Complete the chemical equation for this reaction. So we know the formula for propene is C3H6, right? It is produced twice of whatever is produced here. So to deduce the formula, let's just write that, let's just find out number of carbons. 6 carbons are already used up. Okay, so this is going to be an alkane. The general formula of alkane is CnH2n plus 2. So we have 3 2s are 6. There are 9 carbon remaining. So C9H, 9 2s are 18, 18 plus 2, 20. C9H20. Add that 20 to this 12, you get 32. So the equation is balanced as well. Propene can be converted into polypropene. Name the type of polymerization that occurs when propene is converted to polypropene. When propene is converted to polypropene, double bonds are broken and addition polymerization takes place. Okay. Question number 4. Complete the diagram to show a section of polypropene. Now, let us just simply draw one diagram, right? We have the propene given to us as like this, correct? Let's take that CH3 is here, okay? And 1, 2, 3, one hydrogen here. For this, one hydrogen here and one hydrogen here. What is going to happen is one of these double bonds is going to break and it can accommodate more carbons here. This is how the polymerization takes place. So this becomes our monomer. Let us draw the repeat unit now. So I'll alternatively draw H, CH3, H and CH3, right? Now, sometimes what happens, the compound given in your question is a little bit different. Okay, just keep a check what is happening here. The compound given to us in the question is like this: CH3, H, and this becomes your monomer. Nevertheless, this is correct, okay? But because question is given like this, let's not take any chances, and I would suggest you to not take any chances and draw it like this. It will not be wrong if you draw it just like I had done in the first time. It will not be wrong, but do not take any chances. We'll draw it like this. This brings us, I think, to the end of the paper. Yes, it does. Thank you for watching this paper. If you have any doubts or if you want to solve us other papers, please comment in the comment box below. Other than that, please like, share and subscribe and follow our content. Thank you.